Welcome back to the beginner-friendly Spring channel. Hope you enjoyed the break. Remember, next up we have building flexible APIs with Spring HATEOAS. I've just learned how to pronounce that, so HATEOAS, with Greg Turnquist. And remember, on the right of your screen, you have a link to join the Slack discussion. And otherwise, enjoy the talk.
Thanks, Cora. It's really exciting to see everybody here at Spring One this year. So let me just, I'm going to switch over to my presentation. Let's go put it up here. Okay, let's talk about building flexible APIs. As a starter, who am I anyway? My name's Greg Turnquist. I actually recently released a book back in May, Hacking with Spring Boot 2.3, and there's a link if you're interested. I'm a principal developer on the Spring team. I co-founded the Nashville Jug, and I'm a committer and project lead for several of the Spring projects. And when I have spare time, I like to shoot YouTube videos about Spring Boot, so go check that out. But let's go talk about APIs. Just first of all, what is an API? Before we can talk about a flexible one, we need to talk about what is an API in the first place. Is it a place to get maybe some JSON or XML or some other format of data? Maybe not quite that. Maybe a little better explanation, is it a way to interact with the application? Well, we're getting warmer with that description. Is it a means to extract value from another app that helps your own app if you're trying to fetch some data from somebody else's app and service your own needs? So why don't we dig in and discover what it means to now have a flexible API? Let's start with something that's really simple. And for those of you familiar with Spring MVC, this is about as simple as you can get. We'll just look at it here. The first part tells you what request it's going to respond to, a GET call on this particular templated URI. The parameter gets fed in as a variable here, and then we relay it through to a service that can go look up what this data is and hand it back. So this is nice. This is simple. There's a very clear separation between the web layers, the service layers, the domain objects, and all that kind of stuff. And if we had a payroll system built upon this kind of thing, where we have employee data and we have perhaps Frodo on our staff, this might be the kind of representation we get when we look at that in JSON format. It's data and it's nothing else. There's some value there, of course. That's probably what a lot of APIs out there have, but what about things like updates? What happens if there's changes to the API? What about breaking changes? What happens if the fields change? How do you deal with that? And what about things like backwards compatibility? What if you make changes, but then there's still old clients out there that you have no control over? How do you deal with that kind of stuff? To put that into more concrete terms, imagine your system is real successful and the team decides, hey, we need to make some adjustments based on our new set of customers we've picked up. So that name field really isn't good enough. We need to break it up into a first name and a last name field. So, basically what happens when you serve this kind of data, now that you have this new data where you have Frodo Baggins in the system, but one of the older clients tries to make an update. They try to create a new entry and they're using the old format. How do you respond to that kind of thing? I mean, should you just tell everybody, hey, we don't support that anymore, just update to the new API? Should you roll out another version? Should you run two versions, version 1, version 2? A lot of people seem to enjoy doing that, or shall I say that's what they do is the best way to hedge against that. Maybe you should think about handling both this format and the newer format. Is that something to entertain? Well, there's actually been academic research out there about versioning. What's the impact of versioning on doing where you run two different versions of your API? This study done back 7 years ago, there's a link at the bottom, has 3 different characteristics. The top bar shows what happens if you just run one API, and every time you make an update, you push it out and you force everybody to upgrade. It's shown that after a certain point, the costs start to rise so heavily that changes are very slow down, and every calculation becomes tactical. Is this a benefit or not? The second bar in the middle is when you run multiple versions of an application of an API. The costs rise slower, but there's still a bit there because you're having to maintain multiple versions. And then the third line at the bottom shows what happens if you adopt a compatible version, where you support multiple versions through a single API. And it's a very distinct difference. Why don't we go back to, actually, if we're going to talk about versioning, the man himself, Dr. Roy Fielding, that wrote his PhD dissertation with the concept of REST. He says in the middle of this, there's no need to anticipate such world-breaking changes with a version ID. That's what the host name's for. If you're running example.com, you can have API1.example.com, API2.example.com, et cetera. But it's important to realize that if you look at how the web operates, websites don't have version numbers. And basically, a RESTful API is an API that's built to operate like a website. The only time you really need a new website is when you're making a whole new change and rolling out something big. Another way to frame it is, every time a website makes an update, do you have to update your browser? RESTful APIs are supposed to be built kind of in the same vein. As a side jaunt, if you want to go read this article that just came out about 2.5 weeks ago, this rant, I mean this very well thought out, cogent article by Steve Yegi is very entertaining about problems with rolling out constant upgraded APIs and not having backwards compatibility. So let's go back to our problem and see if we can think about making a more flexible solution. Now here we have, earlier we had basic employee, advanced employee, and here we have now the flexible employee. So we do have that first name and last name field at the top, but if you'll notice a little further down, there's also a getter and a setter for the old name field. This way you can hand back the date, the newer formatted data in the old format that old clients would understand. You also put some handlers in there to support, submitting updates through the old format. This represents a concept that people that have worked in production on database systems for years are already familiar with. It's called the never delete a column. If you talk to a real battle-tested DBA, they'll be like, oh, no, don't delete a column, because what's going to happen is some business analyst who reports to the vice president has an app that you don't know about that depends on that column. And if you delete it, it's going to break him. And then he's going to report to the vice president. Don't delete a column. We've got mechanisms to support that column. We can just move the data somewhere else and sustain that column. This lets you handle the new clients. The new clients can talk through the first name, last name fields. This also supports the old clients. They can keep operating with the old name field by reading the data, writing the data, et cetera. And in this sense, everybody wins. Excuse me. So that's a real solid approach there. And, this is just an example of what a backwards compatible change would be. But you can probably think, how does this concept apply? How can I fit it into my own application? Now, so far what we've talked about when a flexible API is nothing related to any particular stack. This is a concept you can implement whether you're using Spring or some other technology. It doesn't even have to be Java-based technology to use this tactic. But there's other stuff we can do that starts to get us into Spring HATEOAS and what Spring HATEOAS has to offer. And that's specifically where we get to Hypermedia Controls, another facet of Roy Fielding's PhD dissertation. So, a common thing we have is when we need to interact with some particular API, we often have to go to a developer portal. So instead of telling your users, hey, go over and look at this portal server that's got all the details for the API, why don't you just give them the controls right there? We've already seen this on websites when you have next page and previous page, and we give them navigation links on the website. We don't ask people to go up to the browser and type in new URLs. Instead, they can navigate from the site. So why not give the navigation controls right in the API? There, in fact, happen to be multiple standardized media types based upon this concept. In fact, there's a lot of specs governing how to build JSON and XML representations that support the concept of hypermedia controls. And as I mentioned, this is how the web functions. The web is really good at backwards compatibility. Like I said, you don't have to update your browser every time a website changes. It's partly the reason why the web succeeded, because you're not constantly breaking your users downstream. They're able to operate. They're able to keep going with stuff that today pretty much the UIs that everybody builds outside of smartphone devices are web apps. I mean, I rarely run into somebody that builds thick client apps today. Now, as an example, what we're talking about to build Hypermedia Controls, let's go back to our simple API that we had earlier that was represented by this Spring MVC method. What we're going to do is transition to this. Now, that looks like a whole bunch of code kind of thrown up onto the screen there. So let's kind of take it apart. Now, down at the bottom, we should recognize the call to our service object where we looked up that domain object. Only now what we're doing is we're going to wrap it with a Spring HATEOAS type called an entity model. So essentially, we've got the data aspect, which is first name, last name, role, whatever your domain object is, we can put it in there, but we're going to include some navigational links. First and foremost, we're going to include what's called a self link. If people are looking at this particular record, they probably want to be able to know how to get back to it in the future. So give them a link to that. And the self link is built up here. This link to method on operators from the Spring HATEOAS library lets you point at Spring MVC controllers, particularly the one that we're in right now. It's able to look at that method, look at the annotation, get all the information it needs to build a URI link. It also gives you the ability to connect to other operations. In this case, we call these affordances. So the URI on this case, REST employees ID, there's another operation, an update operation to update the same entry. And so in this case, we can link to another controller method by basically just calling the method directly here. And we can chain them together so that affordance-aware media types can render this information, which we'll see here in a few slides. And then finally, you can start putting other related links. In this case, we have an aggregate root link that goes back to all employees. You could just as well put in add links to a person's manager, to their payroll, to whatever other aspects need to be navigated through this API, and add them to the representation. And when we do this, when we add this little bit of extra code here in our web controller, it gives us a richer formatted document here. So we can still see the data that we looked at earlier. We had the first name, we had the last name and the role, but you can also see we have the new name field right here. Excuse me. But on top of that, you'll notice further down, we have a collection of links. In this case, we have that self link. And right below it, you can see the link back to the aggregate root. And if you'd added other links, they would be showing up here as well. In fact, you can put conditional links that based upon the workflow, we'll see them. Now, in addition to that, this document happens to be called what's called HAL-FORMS. It includes further information further down to allow clients to affect change. In this case, here's a template for a put operation. And it shows exactly what the data fields are that the user can apply. There's a signal that they can make changes through the first name field, the name field. It gives them a tip that the ID field is read-only, but that gives you all the information you need in order to act on stuff. In fact, with the little magical JavaScript code, you could have this thing render an HTML form if you wanted to. Now, with all this set up, you're good to go for setting up a flexible API on the server side. But that transitions us to the other half of the problem. You could be serving up Hypermedia all day, but if clients aren't consuming it, then you can ask, what's the point of that? So Spring HATEOAS brings you the tools to consume Hypermedia from the other end. So let's take a quick look at that. So what if you wanted your client to consume Hypermedia, which is what we just talked about? Are you really ready to go register all those messy message converters? Now, if you don't even know what message converters are in Spring land, that's okay. That's kind of a piece of infrastructure that we don't necessarily ask everybody to go learn in order to build a web app with Spring. Do you really want to go look up how to customize a REST template or a web client instance to handle things like HAL and HAL-FORMS and all these various forms of Hypermedia? I say no. You should not have to deal with any of that stuff. That's what framework code is for, to make life easy for you. And in this case, Spring HATEOAS has you covered. Something I like to point out, in recent years, Spring Boot itself has kind of moved away from the idea of let's register a REST template in the app context. Go grab the REST template and go do whatever you need to do to talk to a remote service. Instead, it's more like, let's give you a REST template builder, and then you can apply whatever tweaks and adjustments you need to make to it, and then you can build one as you need it. Because we run into cases where people need to talk to different systems. They need to talk to load balance systems. They need to, when they talk to certain APIs, they need to have retry logic built in, but so they have variations. So in this case, if you register what's called a REST template customizer, then every time you go build a new REST template, it will apply this. So all you need is to grab a hold of Spring HATEOAS's Hypermedia REST template configurer, and it will register the proper handlers every time you create a REST template. So all you have to do is inject that into your code somewhere, and then down here you can do a template.exchange call. So here we're calling the employees object, and we're doing a get call. And you apply this, you can use this little Spring HATEOAS type, entity model type, and it will give you this nice little convenient handle. Earlier we saw the flexible employee object that had the backwards compatibility support built in, and it's wrapped with the Spring HATEOAS entity model type. So this gives you not only the data, but also the links that you need to interact with it. Now, REST template's been around for a long time, so it's a well-supported tool. But maybe if you're in the modern era, you want to switch over to using web client. Well, we've got you covered there. You can create a web client customizer. All you need to do is grab a hold of the Hypermedia web client configurer from Spring HATEOAS and do this one line of registration, and then you're set. Inject web client builder into your app, and then you can build away. In this case, this is sort of the same call, but using web client. So make your call, set your accept header, and say, I want that Hypermedia format of HAL-JSON. I want to apply it, and then I'm going to do something. Don't do that in production code. In my demo code, I did this to do a quick call where there's basically a pretty simple solution here. But if you can, don't do any blocking calls in production code. Now I want to wrap up the presentation here by talking about some of the other features that we have in Spring HATEOAS. So, I've shown you kind of the core basics in how to take an API and make it more flexible using Spring HATEOAS. Spring HATEOAS also has Spring WebFlux support, so you can go build links if you're using WebFlux as well. Spring HATEOAS is adding more media types. The stuff we got a peek at earlier was called HAL and HAL-FORMS, which are some of the most commonly used media types for hypermedia representation. But there's other stuff out there like Uber JSON, Collection JSON, and you can even create your own media type if you want to. We have support for that. We've added support for standardized errors. There's a format called problem JSON, also known as RFC 7807. Spring HATEOAS has seen a lot of battle testing out in production, and so we've been able to get feedback and make significant performance improvements. And there's increasing community involvement. So there are third-party libraries out there to provide things like JSON API or Siren media types. In fact, the project lead for JSON API just made a release yesterday. So go out and follow him on Twitter and then retweet his announcement. We've also made document updates, and we're even getting new ideas on what to put into the framework from the community. So be sure to go check out our website, where you can go find the reference documentation to look up at how to use it and all that good stuff. So I'm going to wrap up here with the big thank you to SpringOne 2020. So be sure to follow us over on the session related to this presentation, and we're eager to hear all your questions and stuff. You can also follow us on the Twitter handle @SpringHATEOAS. And by the way, there's a short window of opportunity. If you go to greglturnquist.com/SpringOne2020, you can enter a giveaway to win a paperback and an ebook copy of that latest book I showed earlier, Hacking with Spring Boot 2.3 Reactive Edition. So if you go to that page, if you sign up, you'll get an email with some links, and you actually get more entries in if you share that then with other people. So if you go share the contest with other people, it enters you in again and again and again. So go check it out. And apart from that, thanks for turning out for my session here, and I hope you enjoy the rest of the Spring One conference.
Thank you, Greg. What a fantastic talk. All right, it's time for our next break, but don't forget, you can still catch Greg in the Zoom Q&A. The link will be in the beginner-friendly Spring channel in Slack. And otherwise, we'll see you back in 5 minutes for the last few talks of Spring One 2020.